Hi, good afternoon, everybody. Nice to see you all. So it's my pleasure to introduce Mr. Ron Bushar. Mr. Bushar is the Chief Information Security Officer and Managing Director of Google Public Sector. He's an ECE Academy of Distinguished Alum. He was inducted in 2025, and we are very happy to have you with us today, Mr. Bushar. So Mr. Bushar, as I mentioned, serves as the Chief Security Officer and Managing Director of Cyber Solutions at Google Public Sector. And he's a seasoned, highly effective and innovative cybersecurity leader with over 27 years of experience in cyber defense operations, cybersecurity consulting, and incident response services in both the government and commercial sectors. Mr. Bushar has a track record of successfully building strategic programs and dynamic teams that deliver innovative cyber solutions, ensure effective security, minimize organizational risk, and ensure mission outcomes for customers. Prior to his work at Mandiant and Google, Mr. Bushar served as the Director of the Department of Justice Security Operations Center, where he led transformative efforts to redefine and restructure key information security and cyber defense operation capability. Mr. Bushar also served as the department's Insider Threat Program Manager and liaison to the National Insider Threat Task Force. In previous roles, he built and led expert teams of cyber defense operators, incident responders, and led teams at several U.S. intelligence and defense department agencies. He began his career in the United States Air Force, serving as an officer in the Information Warfare Aggressor Squadron. So with that, and
I didn't know you were going to read all that. That's really embarrassing.
Thank you. I'm happy to do it.
Yeah.
So without further ado, the floor is yours.
Thank you so much. Thanks everyone for coming today and spending some time with me. I'm gonna have to keep my head on a swivel. It's like a wide room here, so this is good. I'm gonna do a little parlor trick for you guys just to start the event here. Who has an iPhone here? Most people, I assume. Pull your iPhone out for me. Go to the alarm setting and hit new alarm. And then on the hour button, there's a scroll wheel, right? On the hour scroll wheel, scroll that thing, right? Just keep scrolling and scrolling. And some of you already, I'm of course I'm talking to a bunch of engineers, so people already probably know what this is, right? But it's an interesting little quirk of software development, I find, like especially for Apple, who's so sophisticated with their design and implementation, right? But if you scroll that thing long enough, you'll eventually hit the end of it. Instead of just keep going, which you think it's just a wheel of 1 through 12 over and over again, it eventually stops. So somebody wrote that code, right? I don't know how long ago, right? They probably haven't updated it in years because it's an alarm system, like what do you need to change? But somebody wrote that in some sort of logic that said, oh, we will eventually run out of numbers here. So I say that to start the discussion here just because from the perspective, I take a cybersecurity lens to everything I do. It's been my entire career is kind of security, right? So when you think of the way I look at the world, and even if you're not in security, this is always a good perspective, is like, how do things work when you're used or attacked in a way that they weren't designed for, right? And so this gets into this theme of resiliency and how do we think about designing systems, processes, architectures for resilience. And it's always, always in the back of my mind, no matter what I'm doing, it's like, what could go wrong here? What are the things that we haven't thought about? Even if you thought you designed a perfect system or it's a really easy system and it really shouldn't have any vulnerabilities or weird quirks to it, it almost always does, right? Because people are imperfect. Now we're getting into the age of AI. I'm going to talk a little bit about what we're doing at Google, with some AI capabilities. So I think a lot of people tend to think about AI as like it'll save us from a lot of human, mistakes, but I actually don't think that's true, right? Because humans are still designing it. Even when AI starts designing more AI, which will eventually come, right? I still think there's going to be room for mistakes, for errors, or for people who are going to find problems with those implementations. So, and the more we rely on technology, you guys are all very sophisticated. I was talking to some of you earlier about what you're doing in terms of your research and development. We're designing future systems, capabilities, technologies that are going to be foundational, right, to people's lives. Even if they don't see it, they don't understand it, it's kind of behind the scenes. They just use it. And the more we come to rely on those systems, the more important it is that they're secure, right? Or at least they don't break. The brittleness of it, the fragility of those systems, hopefully becomes less less impactful over time. I'm going to talk about a little bit of anchoring on how we see the world from a threat and vulnerability perspective, just to kind of ground you in how we think about cyber threats at Google. This is a combination of the intelligence we developed from a couple of capabilities. We have global capabilities at Google. So one's Virus Total, if you're familiar with that, it's the one's like this malware repository. People upload samples, millions of samples every day. We have, I think, trillions of samples total now in the lifetime of that system. We have our Mandiant and Google threat intelligence teams, which do a lot more of the open source and kind of manual exploration of what bad actors are up to. We also curate a lot of information from breach responses that we do around the world. So we respond to several thousand incidents and breaches every year around the world, both in corporate footprints and government. And so we get to see kind of exquisite information around what actors are actually doing on objectives and environments and how they're maneuvering what they're doing. And then Google has 8 products, I think, that have over 2 billion users, active users. About 11 or 12 with over 1 billion, right? You think about Gmail, YouTube, search, obviously. When you stack that up, we have a huge lens of visibility. I mean, we run about 35% of the world's internet traffic across our pipes, right? Every day. So global kind of terrestrial networking. So we have really, really good visibility into a lot of information. There's a big privacy piece to that, though, of course, as well. So we have to be very careful about how we curate information, but still protect users' privacy. So we take all that information, we dump it into a very large, used to be a graph database, now it is much more of a modern data lake model, and we're starting to apply AI capabilities to those data sets and coming up with insights, which I'll share a little bit with you here. But anyway, this is last year's data. We're actually coming out with a new report for this year. It'll come out soon, but you can see, like, from a cloud, this is purely cloud, not like on-prem infrastructure, not traditional data center systems, right? Cloud architecture is the biggest threat, ironically enough. The biggest initial access is phishing. It's social engineering, followed by stolen credentials. So the weakest point in most cloud infrastructure today are humans, or the way we do authentication, right? Which is still fairly, I mean, you think about the big, especially the big cloud providers, most of their authentication is still password-based, maybe with a two-factor, even two-factor. Many two-factor models today are fairly weak and can be compromised. The rest of these you can see, like SIM swap, so there's a lot of mobile attack vectors. Again, that has to do with bypassing or defeating two-factor authentication. And then social media, so that's more phishing related or social engineering. The only one you see up there that's actually technical is web compromise. So essentially application front-end vulnerabilities that allow access into at least some layer of a cloud environment. So what this tells you, you guys have probably, if you pay attention to the cybersecurity world at all, there's been significant breaches this year, both government and commercial. A lot of them are, land in something like a 365 environment, exchange compromises, those sort of things. They didn't start there though. They started, from these front door accesses, and then they pivoted, right? Or they moved laterally inside the environment. So that's really important to keep in mind. And then what's interesting on the other circle is what are actors doing with that access? The biggest one on here is actually not what you would think, which is normally, okay, I'm breaking into an environment, I want to steal data, I want to steal stuff that's valuable, or I want to extort, ransomware's up there. But it's 11%, right? It's not the biggest number, especially in cloud environments, because it's a lot harder to ransom a cloud environment because you can obviously just restart virtual machines or just refactor the environment. So instead, you see business email compromise. It's email theft. It's getting into people's personal information, or obviously a lot of work gets done with email attachments, et cetera. So there's a lot of valuable information there. It's not well secured. It's easy access. Data theft is number 2, so that makes sense. And then the number 3 one is, guess what? Phishing email distribution. So they're using compromised infrastructure to then continue the chain of access by sending emails from credible accounts and systems, right, to another victim. So there's a chain reaction to these sort of compromises that really create challenges for defenders. So that's cloud, just generally. I want to talk a little bit about how we think about AI security. So this I will tell you is rapidly evolving. When I started talking about AI threats or use of AI from threat actors a year ago, it was very not quite sure what people are even doing with it. We can speculate, and that's what you see. There's some speculation on what's potential, some research and development we do in that area. But we're starting to see much more experimentation and some anecdotes, but actually much better telemetry recently of what actors are actually using AI for. So we have an AI product called Gemini. Some of you might have heard of it. It's not as popular as ChatGPT. We're not number one on OpenAI, but that's fine. We'll get there. But what we find, we can instrument Gemini, and again, this is kind of that balance of privacy and security. But we can monitor the use of our front end and the way people are querying the system for evidence of abuse, right, or misuse. And so we correlate a lot of the information, and we put out some reports on this. These are all open source or public reporting now. So we have this framework for secure AI. That's some general principles of how AI should be used and how it should not be used, but it also includes how do you build AI systems, models, and interfaces to protect against misuse, right? It's not perfect. No security mechanism is. And so through that framework, though, we get to observe what actors are trying to do, and fortunately able to prevent most of those sort of use cases or attacks. But what's important is if you think about a cyber attack lifecycle or chain, right? We are seeing evidence of AI use, or at least attempted use. And again, you have to think we have RNN models. There's a ton of open source. You guys know this. There's a ton of other commercial models. They have varying levels of security. So I'm confident that each one of these steps are being exploited by adversaries in certain ways, right? So reconnaissance, that's not that interesting, really. It's just asking AI for information about a network, a system, a user, right? Doing background checks, those sort of things on people when you're doing phishing attacks. Weaponization is probably more interesting. So we are seeing capabilities being developed where you can rapidly turn a known vulnerability into a payload or into a specific attack vector that can be used. So that's an acceleration of think about it almost as attacker vibe coding, right? So where it might have been more skillful to develop an exploit in the past, now it's much easier. But it's also vulnerability discovery. We're starting to see use cases where adversaries are trying to use AI models to essentially fuzz systems or use black box dynamic testing to find vulnerabilities in the code. Of course, delivery, the biggest one here is social engineering. So again, weaponizing or using AI to craft more believable lures, phishing attacks, those sort of things, both in content and you'll see multimedia now, images, videos, those sorts of things. And then on the installation, command and control side of this, that's all going to be mostly coding based or scripting based, right? So accelerating, again, tool development. A little bit, we believe, this is harder to actually find evidence for. So you think about when especially if you're a sophisticated actor, whether you're criminal or nation state, you're collecting a lot of information and you're running multiple operations. So managing all that infrastructure, managing the information that's coming back, correlating that information, all that sort of stuff. It's a perfect use case for AI, unfortunately, for us as defenders. So we've seen there's some examples here of what, China, some of the bigger adversaries out there that are using these capabilities. And you have to assume that if these countries are doing it, other countries are doing it as well, right? But scripting, deployment tasks, this is more of a data-driven. We have evidence of using, Chinese groups using scripting capabilities as well as data analysis and research tools. Interestingly, DPRK
is fairly advanced on infrastructure, but also on things like social engineering. And there was, again, if you guys pay attention to the news cycle at all, there's been a raft of attacks that are calling kind of IT worker. So essentially false or fraudulent employment to gain access to companies or governments and have insider access essentially. And the way to do that, right, is to create a convincing profile that you're a real person and you have these skill sets, you get hired, you get access, then you maintain that access, right? So kind of you can see how AI would be useful here in terms of creating your resume, creating your backstory, all those sort of things. So it's a really interesting intersection of technology and kind of traditional almost tradecraft and how adversaries are using some of these capabilities. So that's just kind of, I don't want to spend too much time on that. We can, if there's questions about that after, after I'm finished, I'm happy to take those. But that's just in general where we're seeing kind of the AI frontier from a cybersecurity perspective. I want to talk a little bit about how we're using AI more in the context of, okay, how do we make things more resilient and better from a defender's perspective? So again, I'm dating myself, put 1998 up here. That's when I graduated from Virginia Tech with a double E degree, and I didn't know anything about this world, right? So first couple of years I was involved with cyber, it was really kind of almost laughably trivial types of exploitation and systems that were just had no security in them at all, right? It was not even password-based access was pretty simple. So you had the world's first kind of, I'm really dating myself, but the first simple worms were developed. Basic viruses, all those sorts of things were happening back then. Now, obviously, we have is it not coming through?
I don't think so.
Okay.
Sorry.
Now we have, is this better? Now we have obviously much more sophisticated infrastructure, but you got to remember, and again, this goes into this kind of fragility piece I was talking about earlier. The internet is still the same protocols that were running back in 1998 and way before that, right? It's still TCP/IP, it's still, it's still IP-based, it's still layer 2, layer 3 networking. You put a lot more capability on top of that. Okay, so now I have software-defined networking instead of hardware-defined or hardware-based routing and switching in some cases. I've got virtualization, I've got containers, I've got a whole bunch of things stacked on top of still traditional, in many cases, right? The same kind of basic infrastructure that was running over 25 years ago. So what we're seeing is like an evolution, and this is important, right? So the technology's evolved, but it's built on a lot of the same frameworks that are brittle. But also, back in 1998, no one really cared that much unless you were in very specific industries or the government. They didn't care all that much if you broke into a system, right? It wasn't a big deal because there wasn't all that much riding on things. Now, of course, the internet is almost at the point, or call it digital access, right? Is almost at the point of like it's necessary for modern living. If your network goes down, your Wi-Fi goes down, I just experienced this. I had a major lightning strike in my house, and all my systems were basically cooked. And I had no, in addition to the basics not working, right? I didn't have internet. None of my automation worked anymore. My lights didn't work, right? You forget how much runs on this, basic digital infrastructure. And if it doesn't work or goes away, a lot of things break that you don't even think about. So, DevOps, DevSecOps has become a term of art in the cloud world for a couple of years now, but actually probably more than a couple. But it's really more of this idea of how do you do software resiliency and engineering and operations at scale in order to keep things running and deal with outages and problems, right, or prevent them from happening in the first place. So there's a lot that ties in now where it used to be very separate disciplines between software dev, test prod, and then into infrastructure, and the infrastructure lifecycle management was much different. They're much more tied together now. It's Google cannot run its global infrastructure without the concept of kind of combined, operations, software dev, lifecycle, right? We can't push production in a global infrastructure without being thoughtful about how it impacts the underlying hardware, software layers, all those things, right? And you can't manage that by human touch alone, right? All has to have automation to it. So this is really important as you think about building, again, resiliency in the systems. The more human touch points you have, the more vulnerabilities there are, the more likelihood that something's going to fail. Similarly, if you don't fully test, regression test and run through those scenarios where what if somebody did something weird, like keep scrolling on the numbers, what will happen? And you've got to run those scenarios through on a regular basis. The other thing you have to do really is test the system from an adversary perspective. So not just testing from kind of your traditional break fix perspective or running the code to see if there's any bugs in it, but also then, okay, put it into a test environment and see if there's things that break, right, when you integrate it. See if there's vulnerabilities that pop up between the interfaces of the systems. So that testing and evaluation and that thought process of what if somebody does something that we hadn't considered, hadn't thought about, and pivots from kind of the normal user experience, what would happen is really, really important. Along with that, right, there's been this evolution going back. I'm giving you kind of history lessons here. Back in the day when I was in the Air Force, we had this thing called the Rainbow series. It was a series of books, very dense, that defined how the military thought about security, not just, well, at the time it wasn't even cybersecurity, it was system security, right? And it had things in there like need to know and minimum access, right? And role-based access. So it was like the early version of, okay, security by saying the only people who can have access to the system are the people who need to have that access, and as soon as they don't need it anymore, it's revoked, right? So fast forward to today, so we went through a period of time when that kind of went away, right? We built a lot of flat networks. We built a lot of systems where if you have access in one area of the infrastructure, you can basically go anywhere in the infrastructure. It's kind of trusted. It was trusted network-based access, based on one authentication token or one, initial instantiation of an authentication event, and then you had free roam. And we still see that in a lot of situations today when we deal with customers who've had breach events, right? A lot of newer vulnerabilities are being discovered now, not in traditional IT infrastructure, but really in edge devices. So think routers, switches, VPN concentrators, firewalls, right? Security devices. They're usually more firmware-based, hardware-based systems, maybe with a lightweight version of Linux running on top of them. And they don't do a lot of the hardening that we've had to do over the past 20 years with traditional operating systems that interface at the user level, and therefore are, again, brittle. They haven't been updated, or they're running on very old code or old operating systems or libraries, and they're actually very vulnerable. And really nobody was paying attention to them. And in addition to that, they weren't monitored, right? Because in some cases, they're security devices themselves. In other cases, there was really no way to monitor them. So what we found in the past couple of years, our adversaries who are really honing in on, again, researching and developing exploitations for these devices, by definition, are almost like impossible to see initially. So you get initial access, to one of these edge devices that gives you network access, privileged network access into internal infrastructure. And then from there, again, because we've built a lot of networks and infrastructure in such a way that once I have an access mechanism, I can then go find some credentials, compromise those, steal those, and then just pivot in the environment anywhere I want to go. And one set of credentials gets me everything I need. So this whole idea of, once I have one component of access, I have access to everything, is really what led to some of the most significant breaches over the past 4 or 5 years. So to counter that, this whole idea of zero trust network, right? And this has come up in the context of military defense department, but also in a lot of corporate America as well. But it was pioneered by, I would argue it's been pioneered by cloud companies and other kind of hyperscalers, because again, you can't build global infrastructure and one vulnerability takes down your entire, fleet of systems around the world, right? So you have to build this concept in from the ground up that says, my access is based on my need to know at the time, or need to access at the time, a specific, resource, piece of data, whatever it is, and that authentication is constantly happening, right? So I can revoke it at any time. I can selectively revoke it, or one piece of access doesn't give me access to everything, right? That super user concept is really eliminated. And it really comes from this concept of, again, the fragility conversation. You have to assume you're going to have a breach. You have to assume you already are breached. So how do you prevent the blast radius of that breach from really harming other systems, other users, compromising other accounts and systems. And the way to do that is to say, everything you're connected to is untrustworthy. So you have to assume that there's already a compromise in that network connection. So it's not a network boundary condition anymore. It's a user-based, authentication-based condition, right? We still do a lot of network hardening, don't get me wrong. There's still a lot of monitoring that can happen at the edge. But a lot of cloud computing these days really has no edge anymore, right? It's internet connections from the world, right? And from anywhere into these systems. So that creates that really an impossible scenario unless you build this idea of least privilege and enforcing identity as the new perimeter instead of network. All right. So based on that, the other thing, and I talked to some of you about this, I think in an earlier conversation. So I know some of you are working on chips, hardware level, but there's also software-based vulnerability. So supply chain has become increasingly critical. So if I build the systems in a way that are resilient and have the zero trust model, what's another way in, right? From an attacker perspective, well, I compromise the software that's running all of this, right? And then I have an implant essentially, again, undetectable in access that allows me in that would have otherwise been stopped. So I lived this scenario with the SolarWinds breach, right? We had this experience as companies. We're from Mandiant where we were using SolarWinds. Unbeknownst to us, right? Russians had put that implant into software. Really clever piece of engineering when you look at it underneath the hood. They did a number of things that kept it very stealthy. They were able to implant it into the CI/CD pipeline and software development cycle of SolarWinds in such a way that it was not detected by any of the engineering staff there. And that was done, their initial access into SolarWinds was, again, compromised credentials, right? So they got into source code development portions of the infrastructure, insert sign code, right, into the distribution cycle of the way they were sending out firmware updates. Then that lands in victim environments, and then they triggered some really clever DNS callback activity that was super stealthy. Nobody was looking for it, so this call out and C2 channel was established in such a way that it was almost impossible to see, right? So this global distribution of a software implant was predicated on, again, trusted access to software code signing and software dev cycles. So you've got to harden and armor everything you're doing from the start of what you're working on, whether that's software, hardware, or a combination, right? So this emphasis in my mind of security in every stage of what you're doing, including in the kind of the R&D and initial prototyping, is really, really important. And it's a huge area of, honestly, of targeting, from adversaries as well, right? So they want to understand what we're working on, what we're developing, so they can understand how to compromise it before it's even deployed. So you have to be really thoughtful about how to protect that entire life cycle from start to finish. Okay, so enough boring stuff about security. I wanted to talk to you guys a little bit about how to think about your future career path. Kind of feel like an old man up here, talking about some of this stuff, but I'm trying to give you a few things that have served me well in my career. There's no one path, right? There's no one. I can't give you I just talked to somebody about this recently. They asked me what's my one trick or your one secret to, a successful career? I'm like, that's a social media post. I could put that on TikTok, but it wouldn't work, right? It wouldn't work for you. I can't give you the key that's going to work for you. You have to figure out what your brand is, what you're passionate about, and how you're going to develop your career and what makes sense for you, and apply that in the right ways. I really like this saying. I actually don't even know who Karl Barth is, but I found this on one of our internal websites. To me, it's always don't anchor on what you've done or where you came from or what your past successes were or weren't. You can always start a new history for yourself, no matter where you are in your career, and create the next stage of your career cycle. I was talking to a professor earlier today, and when I joined the Air Force and I was commissioned from Virginia Tech, I was a double E student, right? I was actually really into control systems, RF. I was doing a bunch of hardware-based stuff. I thought my career path was going to go down a path, some chain of developing systems, maybe software, hardware. I didn't even know what cyber was, right? I wasn't really all that much into computers, system software. networking. I didn't know any of that. And then the Air Force decided, well, we need somebody to go do this cyber stuff. And I don't know how they picked people, to be honest with you. They probably weren't using AI at the time. They definitely weren't. But, you get thrown into something and you got to make the most out of it. So I got thrown into a lab in San Antonio, Texas, and they threw me in front of a Solaris system and a Linux laptop, and they said, here you go, figure it out, right? That's kind of not quite true. I mean, I had a lot of great mentors along the way, but I had no idea what I was doing, right? And so that's a chance to learn. It's a chance to explore that. And, maybe that's exciting, maybe it isn't. It really worked for me, and it clicked in. And I took that and I just rode with it, right? So you're going to get curveballs thrown at you for sure. And this is something I really like to think about, especially in this age we live in. I think it is unique in a lot of ways. Like, again, when I was your age, coming out of college, there was a lot of things happening. It was seemed crazy at the time. It was the dot-com bubble when I was leaving college and joining the Air Force. And then it was the dot-com bust, right? The internet was just starting. It seemed like a lot of things were happening quickly. But, if you look at the evolution of that, that's 25 years, and not all that much has changed, right, in that time period. Some new technologies come along, but again, the fundamentals weren't all that fast moving. But if you look back at a time period in history in the United States, and this is kind of the what is this called? The Gilded Age, right? So many things changed in this period of time in American history and around the world, really. It must have been dizzying to people, right? So this is a picture from a Flatiron district in New York City in 1902, right? And so it's mostly horses, people, dirt roads, right? And a couple of trolley cars. Now look what happens in 10 years, right? You've got cars, you've got lights, you've got electricity, there were so many things invented in like a 15-year period of time that didn't exist. Nobody even knew what they were, right, before this happened. And then here they are in the real world, and you're interacting with them. And so I feel like we haven't had that kind of transition of change or fast change in a long, long time, right? You can make arguments about, maybe flight or commercial flight, and there's probably some other technology eras, but this one was like tremendously disruptive. We probably are entering, I feel like we might be entering a similar period in our history now with AI. And I know this becomes very esoteric, or, we can be hyperbolic, right? When you start talking about these things, but when you think about how fast, just in the past couple of years, we've evolved from systems that you probably wouldn't even call AI, maybe ML back, a few years ago, into how many models, systems, infrastructure, and the general capabilities of these systems have happened. And this is way out of date, right? This only takes us up to the beginning of 24. And we're just now, I was talking to somebody here earlier about, I think, agentic AI, agentic agent models, where we're getting to the place now where you can start to have not just human interface, large language models, but agent-based capabilities to go do autonomous things for you on the internet and infrastructure. Like, we're kind of at the cusp of some massive changes in the way I think we interact with, obviously, the internet, but the digital world, and what we can do with those capabilities and knowledge. So I say all this kind of to anchor you on, and you're going to laugh at this. So I actually had Gemini generate this chart. This chart is complete BS, right? In my mind, they're like, hey, give me a career spider graph of what's important from a skill set perspective for graduate students in Virginia Tech. And it made some numbers up, right? Like, what's most important? I do agree with one thing it did, though, because it puts communication kind of low in this sort of whole, I don't know if I agree with that. Critical thinking, technical depth, right? The most important thing they put on here is adaptability. I actually do agree with that, right? Because whatever you're working on now, right, whatever you're thinking, and you guys are working on cutting edge stuff. I've talked to some of you about some technologies and capabilities that are way beyond my expertise at this point. But whatever you're working on now is likely to be either obsolete or, moved on to the next iteration before you can blend, right? And so that adaptability to say, okay, take my knowledge and expertise on what I did here and apply it to something new in your career is critically important. You're not going to be doing the same thing, 10 years from now that you're doing today. I guarantee, almost guarantee it. So technical depth, and you guys have that in spades, there's no question about that. But really the adaptability piece of this and how you think about being curious and continuously wanting to learn and adapt will serve you really, really, really well. Again, my career was mostly focused in security for many, many years. When I got to Google, I really wasn't a cloud guy. I didn't know much about hyperscale infrastructure. I didn't know anything about Kubernetes, containers. I didn't know anything about AI, right? I've had to learn a lot of that. And it's really fun for me to be able to say, okay, it's something new, right? Kind of done security forever. I kind of knew that world. So it's really, to me, it's interesting to be able to move to something kind of, even if it's adjacent, apply what you've learned to that new skill set. And I do think in a world where, you might have job eliminations or situations where some job family used to be really, really sought after, and it, overnight it might be replaced, right, by automation. So you have to have that constant adaptability in your thought process of how you think about developing your career, your focus areas, and your brand, importantly too. So again, I'm not going to be TikTok influencer for you guys, but there is such a thing as brand, I think, in your career. Who are you? How's your? It's not just your resume, right? Like, what are you passionate about? How do you think about what you're bringing into the world? How do you work with other people? Do you work well, big groups, small groups? Are you better at, as an individual contributor on your own? Are you good at leading teams, running teams, working on your own? Are you curious? Do you like to explore? Or are you good at focusing on one task at a time and really just diving in and getting to a solution? Knowing yourself is really, really important. And then as you figure that out, finding places where you can put that out in the world in ways that really brand you or help you establish, what you can do and your capabilities are really important. I always encourage volunteering, participating. I didn't realize all the internship not processes, but capabilities you have here inside the incubator, which I think are great in order to get out into industry, even in the government space with DARPA and things like that, are huge opportunities you should definitely take advantage of in your career. And then certifications, I think that having some credentials in addition to what you do from an academic perspective can be important depending on what you're doing in your career, right? So again, it's not really, to me, a proof of knowledge and expertise. It's a proof that you took the time and effort and discipline to, demonstrate a capability that you can put a stamp on, which can be important for people looking to hire, right? I mean, I'll be honest with you, if it's kind of, you're looking at candidates and there's someone who they look very similar, somebody has certs, somebody who doesn't, it can be a differentiator. So I don't want to overemphasize that, but I also think, depending on what career you're going into, that can be valuable. But you guys are you've got amazing credentials coming out of this, this institution, and I think you've got a, immediate kind of leg up in the job market for sure. So leverage that. And then again, I'm not into pithy one word or one phrase kind of advice, but I will say, when that guy asked me what my one trick is, I just said, say yes to everything, right? Don't turn down opportunities. If you have a chance to make a change, or even if here's the piece of advice I would give you. If you have two options and you can't tell if one's clearly better than the other, or they're very close, always go with the one that's changed, right? Always go with the new option. I think that will serve you extremely well because it's kind of it's a pseudo math-based theorem, right? But it's you should pick the next thing because there's so many more opportunities down a new route than what you have in front of you, what you're doing today. So keeping focus on kind of what's next and what you can do next and following that path, I think can be really amazing for you. So I'll stop talking now and maybe you can take questions. That works. Thanks. Are you using this or is it just yell it out? Yes, sir. Yeah. Does it work? Yes, does.
How do you balance security without stifling the developer's ability to develop new features and disrupting their workflow?
Yeah, I love that question because I try to always keep in mind kind of, so I'm a security guy, right? But I tell my team all the time, like, we shouldn't be in the business of saying no. We should be in the business of telling people how to get to yes, but safely and securely. It is tricky, I'm not gonna lie to you, because you wanna move fast, and in order to move fast, you have to usually take barriers out of the way, and security has a lot of barriers, right, by definition, or intentionally. What I would say is the way we try to manage that risk balance where I work is we intentionally create environments that we know are less secure but are open for development, right? And so we can kind of put people in a little bit of a safe space that it's okay if it gets hacked, it's okay if stuff leaks out of there. It doesn't have to be super secure, you can play around, you can work in it. What you have to be disciplined about, in my opinion, is once you're past that prototype stage and you really want to move to production ready, that's when you have to really get into a more disciplined protocol and process for code. Because unfortunately, there's so many threats out there that know how to take advantage of, again, library implant, everything from open source. Google spends an enormous amount of time on open source security, and we found that the open source security, what's called, open source, I should know this, open source initiative for security, right? So for people working on code, that's great, but we wanted to make sure that they don't get compromised, because we've seen Log4j, you've seen some of these breaches where it can have massive effects. So once you get into that next phase of development, it probably does slow you down a little bit, but we have a lot of process around CI/CD pipeline, securing that, testing code, and once you get into more of the production ready state, both dynamic and static testing of code. And then, really, once something gets production ready, we kind of do we tend to want to do a final inspection of that, and then a test once it goes into production. You always want to test something once it goes live, just to make sure you didn't miss something. So it's not a perfect answer for you. I know a lot of people would just rather say, YOLO, I want to be left alone to do the work. And I think there's a room for that. I also just think there's going to be stages where you have to get more disciplined with it. And honestly, again, I always use the analogy with security that I don't want to be like a smothering, somebody who's smothering everything you're trying to do. I want to be the brakes on your car. I want you to be able to feel good like you can go really fast because I'm keeping you safe, right? So that's kind of the mentality picture of that. Anyone else?
Yeah, so you mentioned that phishing is still very, very high, but it's also getting more advanced now with AI. So what have been kind of the challenges that you've seen with training the workforce to do that? I mean, it's already hard enough to train them to not trust every email that they get.
Yeah.
Now that it's so much more advanced, have you found that to be more challenging for the common workforce?
I'm going to say something. Did everybody hear that question? How do you train the workforce to protect themselves against phishing and social engineering? I've come to believe that you can. It's a losing battle. Again, I go back to the analogy that yes, you should train and educate people, but also I've done this long enough where we literally will tell somebody one day what not to do. We'll send that exact attack at them literally the next day, and they click on it, right? So, and you're right. These attacks have gotten really, really sophisticated. We're even my boss at the time, Mandiant, fell for one of these. It was like an Uber-based, attack that was really convincing. So I don't know that you try to secure the user. I don't know that you can. This goes back to the point of you have to assume somebody somewhere is going to get compromised. We actually, as part of our part of our breach that I was talking about earlier with SolarWinds, one of the mechanisms the attackers used once they had the call out from the implant was they wanted to gain additional access. So they actually used a social engineering attack. They looked up in our system new user accounts. Then they called the help desk and said, "Hey, I'm brand new. I need my password reset." Now we have two-factor authentication. If they played I don't have my phone. Can you just send me a text with another key with it, right? Another code. And so we fell victim to it as well. And that's a security company that does this day in and day out. So I really believe that training alone will not solve this problem. You have to build So I'll give you another example that Google has done, right, with Gmail. And again, a lot of this works behind the scenes. So we were, I don't know how long ago, so 3 or 4 years ago, probably, maybe a little longer. Users were inundated with phishing attacks and really malware and all this in Gmail. And there's a real problem because, again, it's got several billion users. We can't manage that with human security. So we had some researchers build. They were really early AI tools before AI was really a thing that was able to really model and map what the patterns of some of these attacks and just kind of silently. It took some training and it took a little bit of like testing and validation, but we eliminated something like 80 or 90% of phishing attacks at one period of time. Now, of course, the adversaries, they change tactics, so you constantly have to keep up. But what we try to do is kind of almost autonomy, right, or autonomic, attack mitigation, and the user never sees it. That's the ideal goal, right? Just like a user should never have to see an actual URL anymore, everything is hidden behind the front end. Same thing with like phishing attacks. If you're doing it right, you're building the systems right, you should be able to do a good, hopefully a really good job, not perfect, but much better job of just eliminating those threats at the front end. And then you have to assume some are going to get through, and then what happens? So I have a compromised user. How do I then detect that unusual behavior from that user to sending out more phishing emails, right? Or pivoting and doing something unusual in the environment, right? Even if it's using standard tools. So you got to have a lot of behavioral analytics behind your user base as well. It's a layered defense. There's no silver bullet to it, but training almost never works. I hate to say it. Yes, sir.
Yes, I have a question from Zoom.
Mm-hmm.
So, what's your thought or insight in how AI could be applied for the space cybersecurity industry?
Yeah, I mean, there's a lot there. I forgot to cover some of that in my discussion. We are working on, we have a very specific large language model called StackLM that's been trained on security, both all of our corpus of cyber attacks, but also expert training on how we respond to those attacks. So we're constantly evolving that model. And so that is kind of it's a co-pilot type of model today where it sits alongside an analyst and it's presenting course of action decisions or it's presenting analysis of what it's seeing, or you can ask it questions, right? Pretty traditional LLM. What does this threat actor typically do? What are the IOCs? How should I hunt for this? But we're really getting to the stage now where, again, it's agent-based instead of just passive, something that's helping the user. So we're going to be in a mode very soon with AI agents that will be in the environment, essentially API'd into your security telemetry, firewalls, proxies, identity systems, right? And they'll be doing a couple of things. One will be active hunting and alerting on new threats that pop up in real time, and then active interdiction, meaning, okay, identify something, maybe it pops up can I remediate? Yes, and then the remediation is a block or a removal or something else that it just does for the user. So you don't have to manually intervene. That's where I think a lot of AI is going. The other piece we're using it pretty aggressively now is kind of disruption. So we released an internal tool we called Big Sleep. I don't know why they called it that, but essentially it was taking the use case I gave earlier about what adversaries are doing with AI. We turned it around and said, how can we discover our own vulnerabilities in software? Pointed it at some of our software stack, again, trained on software dev and software vulnerabilities, and had it kind of do some fuzzing around certain software libraries and systems, found some vulnerabilities, and then was able to go out, again, through an agent-based model and actually remediate or block those, those vulnerabilities from actually being used, right? And so we actually got ahead of some attackers that had similarly discovered those vulnerabilities, but we found them first, which is what you want to do. So I think the automation of discovery, detection, disruption, and remediation are all places where we have to start moving at machine speed, or the adversaries are just going to win every time. So, sir, Google shirt.
So regarding that deconstructing zero trust, so I don't know if you're familiar familiar with the term information-centric networking, which was introduced by Mandiant in a Google talk in 2006.
Yeah.
So yeah, named data networking is like a particular field under this.
Let me just stop you for a second.
Oh, you can't hear.
Yeah. It's a long question.
Yeah, that's fair. Go ahead. So in named data networking, we technically name each piece of data, and each piece of data also has a signature. So we have this granularity at authentication and authorization of each piece of data, not even user services. And we also have like trust schemas that can fine-grain define the relation between the keys and the piece of data that they can sign.
Yeah.
So I wanted to know if Google has like a team working on these new kind of architectures, like in the end, or.
So I'm vaguely familiar with what you're talking about. I will say we have a lot of people working on a lot of research and development in this area. I'm not familiar, unfortunately, with the specifics of those sort of systems. What I will say, again, just giving you my experience, is these kind of schemas can be fairly brittle if you're not careful about it. Meaning, like, if you have to have perfect implementation or they don't work, right, it can be really difficult to implement. And again, you're typically riding, when you're dealing with real world environments, you're never in a siloed system that's perfect for you. There's interfaces, there's pieces you got to deal with. You know, I have to interface with AWS and Azure and on-prem, and they all have different schemas. They all have different unstructured data. You know, so I think this is actually where AI can be really useful. So you can have a schema like that or a protocol idea that says, okay, we want to be able to tag information or at least assess information, understand where it is, where it's going, who's accessing it. But and the military's tried to do this for a long, long time. I've worked in systems where you have to rely on users to tag something and get it wrong. You have to, or you rely on metadata, and metadata is wrong, right? So there's a bunch of these things that sort of work, but they can be really brittle. So I think I go back to, let's define what you're saying, but then let's have AI actually do the heavy lifting of, okay, what's this piece of data? You know, how does it fit in, and have it do the work? Because if you try to do that manually, it's never going to work. So, yes, I think there's probably research going on there. I can try to get back to you on the specifics of that. I'm just not as close to it, but I do think these are kind of the frontier ideas that we're trying to think about, like in the future of, again, scalability and resiliency in our systems in particular.
Well, it's a question I have.
Yep.
So to me, you are an excellent example for adaptability. You were trained at Virginia Tech on systems, control,
Yeah.
and now here you are, then, security at Google. How did you do it? The adaptability skill, how did you develop that? How did you educate yourself so that you are on top of things? Can you give us some insight on how you did that?
Do you want to take that back from me, or can you hear me now?
Oh, yes.
That's a broad-ranging question, and it's going to make me seem like I'm bragging too much, which I just don't like to do. So I was actually talking to Professor again here earlier about this a little bit. Like, my first year at Virginia Tech, I failed miserably. I think I had a 1.8 grade point average or something. I was overwhelmed. I was doing core cadets, which took a lot of time. I was way behind on all my studying, all my homework. I failed every test. I came from a situation where I was, high school was really easy, so I didn't develop any skill sets on how to properly learn, right? So I got a crash course in that at Virginia Tech, and a lot of you probably, if you've gone to challenging undergrad programs, you probably may have experienced something similar where it's like, oh my God, like this is way different. So I do think actually, you guys are in a place now where by dint of you being here, you've learned how to learn. You've learned how to figure out when you're presenting with, hey, I need help with this, or I need you to do this, and you don't know how to do it. You figured out mechanisms and mechanics on how to be focused, disciplined, and learn what you need to in order to be successful in that new task, right? I had to learn that over the course of a couple of years of tech before it really kind of snapped in for me. And I think that's carried me well,
through my entire career. So having a great education, which you all have, is a perfect start. But then you have to apply it, right? So then I will be honest with you, you can fall back into lazy habits. You might get a first job where it's not that challenging, or you nail it right out of the gate because you know everything, and then you can fall back to, okay, I don't need to press myself anymore. That wasn't the case for me because the Air Force threw me into stuff that I had no idea what I was doing. I had to learn entirely new operating systems. I had to learn programming, scripting, networking. I had to teach myself TCP/IP. I had no idea what any of that was, right? So you have to, goes back to what I said earlier, you have to be relentlessly curious. You have to have motivation to want to learn what you're being asked to work on, or what you're choosing to work on. And then you have to apply your skills of learning and discipline to get there, right? And look, you also have to know when to pivot. So a story I've told before, when I left the Air Force, I went to work for a defense contractor, which kind of, pluses and minuses to that. But I got put into a role where I learned a lot, but then I was developing by hand. I was doing like assembly language work, right, which was way beyond my skill set, frankly, and also like I didn't like it. It was tedious. It was boring. It didn't click with me, right? And there were people I was working with on my team that were like amazing. They were working on code, and they were developing capabilities that would, it would take me 6 months. They do it in 6 weeks, right? So I kind of had to look honestly at myself and say, am I ever really going to be as good at this as these other guys? Probably not. So I intentionally, in that period of my career, I said, I need to make a pivot. I talked to my management team. I was like, I really like to go work on something else because I don't think I'm all that effective here, right? What else can I do for you? So I moved into a different role. I moved into more of an operational role, customer facing for me, and worked a lot better. So you have to be honest with yourself sometimes too. Just because you have like a job or an opportunity and it looks amazing on paper, it sounds really cool. If it's not clicking with you, you have to give it an effort. I'm not saying quit first day, but you give it an honest effort. You have to really be able to evaluate as you go through that journey. Is this really for me? Am I passionate about this? Can I be really good at it? And find somebody said this once to me. This time in your life is about finding what you're really, really good at, and then just driving at that, right? And it's not going to be the same for everybody. You're all coming out of here with kind of similar education backgrounds, but you're each going to find a different path and niche for you that's really going to click in. And the trick right now is to that's why I kept saying, try the next thing, right? Because you won't know it. If you get stuck in one area and it's sort of okay, but it's not great, you won't know if you really hit it until you try some other things, right? So I think saying yes, trying, pivoting, is really, really beneficial to you early in your early stage career.
Thank you very much.
Yep.
Reached to the end of the
Okay.
hour now.
Thanks for spending an entire hour with me. Hopefully I didn't bore everybody to death. I really appreciate the time, guys, and I'm really excited about seeing you guys here. It's kind of the future of our technology leaders, which makes me really hopeful for the future. So
Thank you
yeah.
very much.